This history starts in 1970 with the publication of a relational model of data for large shared databanks, an academic paper by Edgar F. Cobb. That original paper introduced a beautiful way to model data. You build a bunch of cross-linked tables and store any piece of data just once. Such a database could answer any question as long as the answer was stored somewhere within it. Disk space would be used efficiently at a time when storage was expensive. It was marvelous. It was the future. The first commercial implementation arrived in the late 1970s, and during the 80s and 90s, relational databases grew increasingly dominant, delivering rich indexes to make any query efficient. Table joins, a term for read operations that pull together separate records into one, and transactions, which meant a combination of reads and especially writes across the database, but that need to happen together, were essential. SQL, the structured query language, became the language of data, and software developers learned to use it to ask for what they wanted and let the database decide how to deliver it. Strict guarantees were engineered in to prevent surprises. And in the first decade of the new millennium, for many business models, that all went out the window. Relational databases, architected around the assumption of running on a single machine, lacked something that became essential with the advent of the internet. They were painfully difficult to scale out. The volume of data that can be created by millions or billions of networked humans and devices is more than any single server can handle. When the workload grows so heavy that no single computer can bear the load, when the most expensive hardware on the market would be brought to its knees by the weight of an application, the only path is to move forward from a single database server to a cluster of database nodes, working in concert. For a legacy SQL database architected to run on a single server, this was a painful process, requiring a massive investment of time and often trade-offs and sacrifices of many of the features that brought developers to these databases in the first place. By the late 2000s, SQL databases were still extremely popular, but for those who needed scale, there were other options. NoSQL had arrived on scene. Google Bigtable, HDFS, and Cassandra are a few examples. These NoSQL databases were built to scale out easily and to tolerate node failures with minimal disruption, but they came with compromises in functionality. Typically, a lack of joins and transactions or limited indexes, shortcomings that developers had to constantly engineer their way around. Scale became cheap, but relational guarantees didn't come with it. The legacy SQL databases have tried to fill the gap in the years since with add-on features to help reduce the pain of scaling out. At the same time, NoSQL systems have been building out a subset of their missing SQL functionality, but none of these were architected from the ground up to deliver what we might call distributed SQL. And that's where CockroachDB comes in.